In this video, I'm going to walk through a notebook where I'm trying to answer two questions. One, for a given document collection and indexing configuration, do the libraries RAGatouille and ColBERT produce the same index? And two, for a given index and search configuration, do RAGatouille and ColBERT retrieve the same passages, scores, and recall at 10? And so I'm going to walk through my Jupyter notebook answering these questions. So the first thing I did is I loaded some data, and I've currently been working with the UKP Lab DAPR document aware passage retrieval dataset, and the conditional QA dataset is the smallest dataset they have in that set, which has about 70,000 rows. So to do some initial experiments, I've just used a 1,000 row subset. So for RAGatouille, we have the RAG pre-trained model from pre-trained, so I'm using Answer AI's ColBERT small v1. I'm going to pick 1,000 items to index, and I'm looking at the configuration, the ColBERT config, before we index, and I notice certain things. So the search-related parameters are all none, because that's not what we're doing right now. The k-means and iters is 4, n bits is 1, index b size is 64, and so on. So just making sure that I understand what the configuration values are. And to match ColBERT, I'm forcing RAGatouille to use the FICE implementation of k-means clustering, and I'm only doing this indexing on the first 1,000 items in my dataset. So this takes I think it's just a few seconds. And it's about 1.2 megabytes. And these are the files that are generated with the index. So we have a combination of PyTorch tensors as well as some JSON files. And if we look at metadata JSON after indexing, we see a number of values which have been updated because of the dataset size and some of the automatic updates that take place in RAGatouille. So n bits are now 4 because it's a small dataset size. B size is up from 32 to 64. Docmax lens is down from 300 to 256. And now we have a new num partitions, which is 1024, which is the number of clusters that we have, which is the number of centroids that we have as well. And so you can look at the metadata JSON file here as well. Okay, so I've just documented before indexing and after indexing, and I'm focused on after indexing because that's what RAGatouille sets. So I'm going to use the same configuration values that was the after indexing value. And inspecting the ColBERT config default values, we can see that there is a number of differences between the two. So when I'm running the ColBERT indexing code, I define the config, which is the ColBERT config object, and then I set the values that RAGatouille has set during indexing or after indexing. So we run this, and one note is that there's this error, which I think still appears. So there's this MKL service Intel, MKL threading layer is incompatible, So I found something online where you can set that environmental variable to 1, and it'll still show the error message, but it will continue with the script. So that's why I have this environmental variable being set. Cool. So now we have our RAGatouille 1000 subset and our ColBERT 1000 subset indexes. The ColBERT index is 100 kilobytes or so smaller, and that's because it doesn't have a couple of the files that RAGatouille has, which we'll talk about later on in this video. But it generally creates the same files: metadata, codes, centroids, IVF PID, doclens, etc. So I'm listing out all the RAGatouille files, and these two are unique to RAGatouille. And then I'm listing out all the ColBERT files, all of which are also generated by RAGatouille. So if we look at the metadata JSON files, everything that is relevant to indexing matches. So the number of bits used for compression, the number of iterations used for clustering, the dimension size, the maximum length of the documents, the number of centroids, the number of embeddings, and then the average length in terms of embeddings per document, and of course the checkpoint that's being used. So then I created this helper function. First I did this manually, and I saw that in some cases, some of the PT files had tuples, and some of the PT files had tensors. So if it's a tuple, then in each case it was always two objects in the tuple. So I wanted to make sure I could see the shape, I could print the sample values, and then the key thing is I wanted to see if the RAGatouille and the ColBERT items are matching, and if so, how much are they matching? So we basically get a Boolean tensor here, we convert that to a float, and we take the average. And so this is going to be 1.0 if it's an exact match, and then 0.0 if it's a zero match, and then in between if there's a partial match. So then I just go through the RAG index, the RAGatouille index and the ColBERT index, and then I'm passing the relevant files, and then here it's spitting out the sample values, the shapes, and then the match. So the codes, which I believe are the centroid IDs that correspond to each of the 15,000 plus token embeddings, fully match. The residuals, which are the compressed difference between the centroid and the token embeddings, there's a full match there. The centroids themselves, and these are the actual centroid embeddings, these are not compressed, so you can see float values. And there's a 1024 of them, and the 96 embedding size of the Answer AI ColBERT v1 small. And we see a full match. The IVF PID, this is a match. This is a matching between unique centroid IDs and unique token embedding IDs. That's full match. The buckets, which are the cutoff values for the compression, that's a full match. And then the average residual, which is a single value, I'm not sure, oh, there we go, 0.015, that's a full match. So all of the tensors that indicate important information about how the indexes are created are a full match between RAGatouille and ColBERT. So this was a good first start. And then there's a JSON file which shows how many tokens there are in each document, and that was a full match as well. So at this point, I feel pretty good. And I'm willing to say, like, okay, I'm pretty sure RAGatouille and ColBERT generate the same index, which is expected, but it's cool to see, tangibly. So with the 1000 subset confirmed, I now index the full document collection, which is 70,000 rows. So that's still pretty small, and it doesn't take that much time for these frameworks to index them. Now it's 45 megabytes instead of 1.2 megabytes. And now we have some additional files, but they're all kind of the same thing. The ColBERT index is a bit smaller, again, because we don't have a couple of the JSON files that contain lists. So now I've kind of wrapped everything in a function, and here I'm looking at all of the parameters that I'm interested in the metadata.json. So I load those in, and then I loop through each of the parameters I'm interested in and assert that they're equal between the two frameworks' metadata, and they are. And then I've simplified my comparison of PyTorch tensors or PyTorch objects. So now if it's a tuple, I'm asserting that the shapes are equal and then the values are equal. And then if it's not a tuple and it's a tensor directly, then I'm asserting that the shape is equal and that the values are equal. And so here are the PT files plus the JSON file of interest. If it's the JSON file, I load the JSON object and I assert that they're equal. And these are just lists of integers. And if it's not a JSON file, and if it's my PT files, then I'm comparing the RAGatouille file with the ColBERT file. And this runs without assertion errors, so all artifacts are equivalent. So this answers my first question, right? So I had these two questions. Do they produce the same index? And the answer is yes. So the second question is, for a given index and search configuration, do they retrieve the same passages /scores /recall at 10? And the reason I'm asking this question is that early on I had run some experiments where I was getting different retrieved passages and scores between RAGatouille and ColBERT. And long story short, and we're going to see a bit of that long story, but long story short, it was because I was not setting the configuration correctly. So if you look at RAGatouille in the load searcher method in the plaid model index, you'll see that it'll set some of these configuration values based on dataset size. So in our case, our dataset is not less than 10,000, it's 70,000, so it is less than 100,000. So n cells is 4, and centroid score threshold is 0.45. And we're not using force fast, so the number of documents is 1024. So this is the kind of final filter set before it retrieves your top K. So I set those 3 values here, and I just check that those are indeed what are set in the config. I run rag.search, and I store my results where the ID of the query is the key value. And then I have a dictionary where the passage ID that's retrieved corresponds to the RAGatouille score, or the ColBERT score that's been retrieved. And then I use PyTorch to get the mean recall, which is 0.286. So this is my baseline that I'm going to compare everything to. So now I use the same config values for ColBERT. ColBERT requires the dictionary for its queries, so I build that. And then this is where I learned a lot on Twitter, and I always learn a lot on Twitter, where I posted how I wasn't getting the same search results. And Benjamin Clavier, who's the author of RAGatouille, kindly took some time to explain that RAGatouille has a policy to never truncate queries, so it updates the query length to be at least the actual query length, whereas ColBERT is truncating it to 32 tokens. So I've linked the function in RAGatouille, helper function that handles this. So when I'm indexing ColBERT, or sorry, searching with ColBERT, I have to take into account that the query length has to be this heuristic that RAGatouille uses. So it takes the basically number of words and multiplies it by 1.35, and that is the query length in terms of maximum tokens. So I'm iterating through each query, I'm getting the query length, I'm passing that query length to the ColBERT config query maxlen, and I'm running search on that query to get the top 10, and then I'm saving the ColBERT results in the same way, where the key of the ColBERT results dictionary is the ID value from the dataset. A key difference is that ColBERT does not store the passage IDs that are in the dataset collection, in the document collection. ColBERT only stores the index. So I do a little bit of a mapping here where I'm grabbing from my passages for that index, I'm grabbing the underscore ID attribute, and that's going to be my key. And then I have the score for that index and corresponding ID. So I run that, run it through my recall script, and I get the same value of 0.286. And another check is I iterate through all my ColBERT result keys. And then for each key, I iterate through each passage score pair. And then I assert that that score is the same in the RAGatouille results. And it is. So I'm like, okay, great. This is 100% confirmation that once you set the configuration correctly, given this query length heuristic, you get the exact same retrieved passages and the exact same scores between RAGatouille and ColBERT. Cool. So just to be thorough, and just because I was interested in the challenge of trying to do this, I wanted to search the RAGatouille index with ColBERT and search the ColBERT index with RAGatouille. So, kind of, if this works, then, these two frameworks are thoroughly interchangeable when it comes to getting the same index and getting the same search results. So I now pass to ColBERT, I pass the RAGatouille index root. Everything else stays the same. I have my query length heuristic. I have my ColBERT config. I run that. And if I compare my new ColBERT results 2 with my original ColBERT results, they are equal. And I get the same recall at 10. And then we flip it, right? So now I'm going to search the ColBERT index using RAGatouille. To do this, I need to create two files that RAGatouille is going to expect. So RAGatouille expects collection.json, which is basically just a list of all of your collection texts. And then PID docID map, which is a list of the index in the list to the whatever ID that you want to define. And in our case, the dataset already comes with an underscore ID value, which is what we want to use. So if we look at the RAGatouille path and look at the collection, we'll see it's just a list with all of the document passages. And if we look at the first 5 values, this corresponds to the first 5 items in our document collection. If we look at the PID docID map, we see a stringified integer, and then we see the underscore ID that is existing in our passages dataset that we downloaded from Hugging Face. So here's the last ID, 69198, because there's 69199 values, and that happens to have a 651-91 ID. So if we look at the very last passage in our dataset, here's the passage ID that matches here. So saving the collection.json in my ColBERT index path is very straightforward. I just dump the passage text. And the PID docID map is still pretty straightforward. I stringify the integer as the key, and the value is the underscore ID attribute in my dataset. And I just do a quick check, write that to a JSON file, make sure that the PID docID maps that I have are equal to what RAGatouille has, and kind of doing it in both directions. And now, with a single line, I can do rag pre-trained model from index, give it the ColBERT index path, and now that it has those 2 files, it will build the index accordingly. And it takes a couple seconds and it's done. So now I run my configuration. Over here, I define the number of cells it's going to search. N cells is basically how many centroids closest to the document embedding do you want to search around. And then there's a centroid threshold check that happens in the Plaid scoring pipeline. And then this is the number of documents before we filter it down to the top 10 in our case. So now I'm running search with rag2, storing my results. And as you might expect, I'm running the same checks. I'm iterating through my previous results, and I get the same scores. And I run this through my script to evaluate it using PyTorch, and I get the same mean recall at 10 of 0.286. So with that, now I have fully answered both of my questions, and they are a capital YES, yes. Yes, they produce the same index, given the same document collection and the same indexing configuration. And yes, RAGatouille and ColBERT retrieve the same passages, the same scores for those passages, and produce the same recall at 10 metric, provided that you give it the right configuration, including the query length heuristic that RAGatouille implements. So this is really awesome. Every time I interact with these frameworks, I always learn a lot, whether it's about the frameworks themselves or I learn a lot about information retrieval in general. And so now I can move forward in my indexing and scoring experiments using either library. So if I want to use ColBERT, I can use ColBERT. If I want to use RAGatouille, I can use RAGatouille. If I want to make the index with ColBERT and score with RAGatouille or vice versa, I can do that. So it gives me a lot of flexibility with whatever situation or circumstance that I'm dealing with. So this is also a blog post that I've published earlier today. So all the code is available in that blog post. So I'll put that in the video description below. But thanks for watching. Please make sure to like, comment, subscribe, and I will see you in the next video.